January 31, 1945, Clark Air Base, Luzon. The humid afternoon light glinted off the aircraft before Major Frank T. McCoy, who steadied his hands as he photographed the machine that should not have existed in this condition. Before him stood a fully intact Mitsubishi G4M Betty bomber, its tail marking 763-12, gleaming as if it had just rolled out of a factory. No Air Force, McCoy thought, would knowingly design a bomber like this. Its long, cylindrical fuselage, nearly 20 meters from nose to tail, rested on its tricycle landing gear like a massive polished cigar left on the runway. The 25-meter wings showed no combat scars, and the 14-cylinder engines appeared untouched. This was not a wreck dragged from the jungle. It was a fully operational aircraft, abandoned as American forces advanced. Yet nothing baffled McCoy more than what he discovered when he crawled into the interior through the inspection panels. Inside the wings, the fuel tanks had no protection at all. No self-sealing rubber, no armor, no fire suppression lines, only thin aluminum, barely 2 millimeters thick, separating thousands of liters of aviation fuel from enemy gunfire. McCoy, head of the Technical Air Intelligence Unit, Southwest Pacific, had examined dozens of crashed Japanese aircraft across the theater. But nothing compared to this revelation. This bomber, captured whole during the liberation of Clark Field, would unravel a Japanese design philosophy so foreign to Western doctrine that analysts would spend months piecing together its implications. The discovery would reshape American tactics, intelligence assumptions, and aircraft engagement doctrine for the rest of the war. Behind this moment lay 4 years of hard lessons, beginning on December 8, 1941, the morning after Pearl Harbor. That day, 82 G4M bombers and 26 G3M NAL bombers lifted off from Formosa, heading for Clark Field, achieving total surprise. Flying at 20,000 feet, well beyond the reach of American guns, the first wave dropped more than 600 bombs on the airfield. Zeros followed, shredding everything that remained. Of 17 B-17s on the ground, 12 were destroyed. Nearly every P-40 was reduced to flaming debris. In less than an hour, American air power in the Philippines had been erased. One of the few surviving pilots, Lieutenant James Harrington, watched helplessly from a shelter as the formations withdrew. What struck him most, he later wrote, was the precision, the Bettys in perfect formation, out of reach, untouched. Their performance stunned American observers, their ability to strike from 460 miles away, at ranges no American bomber could yet match. And their first year only amplified their reputation. On December 10, 1941, just 2 days after striking Clark, Betty bombers joined G3M NELs in the attack that sank the HMS Prince of Wales and HMS Repulse, the first capital ships in history sunk at sea by aircraft alone. Japanese torpedo bombers executed their runs with frightening accuracy, sending both ships to the bottom in minutes and killing 841 sailors. Through the first months of 1942, Betty bombers appeared in every major Japanese offensive, hitting Darwin from 1,500 miles away, striking Port Moresby, and launching raids from Rabaul to Guadalcanal, distances that defied Allied expectations. Their range granted the Japanese strategic freedom the Allies struggled to match. But this dominance depended entirely on one condition: lack of opposition. When Bettys flew unchallenged, they were deadly. But once Allied fighter strength increased in mid-1942, the truth began to emerge. By mid-1942, the illusion of Japanese invincibility finally cracked. As American fighter strength grew, first with F-4F Wildcats and later with F-4U Corsairs, pilots began reporting something almost unbelievable: the Betty bomber caught fire with just a few rounds. On August 8, 1942, over Savo Island, American fighters intercepted 23 Betty bombers heading toward Guadalcanal. What followed became one of the most lopsided air combats of the war. 18 of the 23 Bettys were shot down, nearly 120 airmen killed. Pilots described the same shocking weakness. A single burst anywhere along the wings or fuselage ignited the aircraft instantly. It burned so quickly and so violently that crews had no chance to bail out. The Betty earned new American nicknames: Flying Cigar, Flying Zippo, One-Shot Lighter, names that reflected exactly what pilots witnessed. The pattern repeated through August, September, and October of 1942. Every time Betty formations left Rabaul for Guadalcanal, American fighters tore them apart. The aircraft that once struck from beyond retaliation had become an easy target, fast, long-ranged, but catastrophically fragile. For the Allies, these observations raised urgent questions. Why would Japan design a bomber with such a fatal weakness? The answer came slowly as the Allies captured increasingly intact examples of the aircraft. The first key revelation arrived in November 1942 when Australian forces captured airfields at Buna, uncovering abandoned Japanese aircraft. Technical air intelligence engineers opened the wing panels and immediately understood the truth. The Betty's fuel tanks were completely unprotected by design. No rubberized layers. No armor. No baffles. No fire suppression tubing. Just thin aluminum skin holding nearly 5,000 liters of high-octane fuel. This wasn't a field modification. It wasn't the result of shortages. It was how the aircraft was meant to be built. American bombers, B-17s, B-24s, B-25s, had all used self-sealing tanks since 1941. Japanese designers, meanwhile, had deliberately removed such systems to save weight. The weight savings were enormous, over 500 kilograms, which they reinvested directly into fuel capacity and range. In theory, the decision made sense. Japan needed extreme range to operate across the Pacific's vast distances. But the cost became horrifyingly clear at Guadalcanal. Every hit was fatal. Every tank was a bomb. Every mission became an act of luck. When American engineers examined multiple Betty wrecks, they discovered a consistent pattern. Fuel tanks positioned directly in the line of fire, centered in the thickest part of the wing where bullets and cannon shells passed most frequently. Even small-caliber hits caused immediate fuel leaks. Cannon rounds ignited entire wings. The Betty's vulnerability wasn't a flaw. It was the direct result of a design philosophy that prioritized reach over survival. And that philosophy was about to be exposed even more dramatically. The true scale of Japan's miscalculation finally emerged when American forces captured a fully intact Betty at Clark Air Base in January 1945, tail number 763-12. Major Frank T. McCoy and his intelligence team spent weeks dismantling the bomber piece by piece. What they uncovered confirmed every battlefield rumor and revealed how deeply the design philosophy had been baked into the aircraft's structure. Inside the wings, they found 8 massive fuel tanks, arranged in pairs, each one thin-skinned, unarmored, and positioned exactly where enemy fire was most likely to hit. No baffles to slow leaking fuel. No rubber layers to self-seal punctures. No insulation to prevent vapor ignition. It was as if the aircraft had been built to burn. Yet the numbers told a different side of the story, one that explained why Japan had accepted such catastrophic risks. Using this light construction, the Betty achieved a range of over 6,000 kilometers, farther than any bomber in the world when it first entered service. It could fly from Formosa to the Philippines, from Rabaul to Guadalcanal, or from the Marshalls to Wake Island, all without refueling. In 1941 and early 1942, when the Allies were still reeling, this range changed everything. American and British commanders repeatedly misjudged how far Japanese air units could strike. The Betty exploited these blind spots again and again. But the Clark field analysis revealed the ugly truth behind that range. Nearly 3,800 kilograms of fuel stored in tanks that could not survive even a handful of bullets. When the intelligence team calculated the structural load paths, the results were even more shocking. A single cannon hit to the wing root, a common firing angle, would rupture 2 tanks simultaneously, flooding the aircraft with atomized fuel. One tracer round was enough to ignite the entire bomber. The engineering reports concluded bluntly, crew survival in the G4M is statistically improbable once enemy fire reaches the fuel system. The data lined up with the grim combat records from 1942 to 1943. In the Guadalcanal campaign alone, Japan lost over 100 Betty bombers, roughly 1 aircraft for every strike mission launched. Entire squadrons disappeared in weeks. Replacement crews trained rapidly, but they faced impossible odds. Even veteran Japanese pilots admitted bitterly that the aircraft offered no forgiveness. One flyer later summarized the experience. "In the Betty, our life expectancy ended the moment we were seen." As the Americans analyzed the bomber at Clark Field, they realized something else. The Betty was not a poorly built aircraft. It was a brilliant machine designed for a completely different war than the one Japan ended up fighting. The deeper American analysts dug into the Betty's origins, the more they realized that its fatal weakness was not an accident. It was the direct result of the Navy requirements issued back in 1937. Japan's naval staff had demanded a bomber capable of extraordinary range, over 4,700 kilometers empty, or 3,700 kilometers with an 800 kilograms torpedo. To meet that goal, the design team led by Kiro Honjo at Mitsubishi faced a brutal equation. Every kilogram added to the aircraft reduced its reach. Armor? Too heavy. Self-sealing tanks? Too heavy. Fire suppression? Impossible to include. Honjo's engineers ran the numbers and discovered that simply equipping the bomber with proper self-sealing tanks would reduce range by nearly 1,000 kilometers, destroying the core mission requirement. And so the choice was made: protection would be sacrificed for performance. The first prototype flew in October 1939, meeting every specification the Navy demanded. The bomber could cross ocean distances that stunned Western analysts. In 1941 and early 1942, this design seemed visionary. The Betty struck targets the Allies had assumed lay far beyond Japanese reach. It could launch from distant bases, hit enemy fleets, and return home without refueling. Its torpedo attacks played a key role in the sinking of HMS Prince of Wales and HMS Repulse, marking the first time capital ships were sunk at sea solely by aircraft. But the aircraft's fatal flaw emerged as soon as the Allies recovered from the shock of the early months. By mid-1942, newer American fighters, F-4F Wildcats, then F-4U Corsairs, and eventually F-6F Hellcats, began entering combat in large numbers. These aircraft saw immediately what the designers had sacrificed. American fighter tactics evolved rapidly. Pilots learned that they didn't need to aim for engines or cockpits. One burst directed anywhere near the wings ignited the bomber like a lantern. Survivors reported that attacks often produced no debris, just a sudden flash in the sky and falling fire. As American radar networks improved, interceptions became routine. Range no longer protected the Betty. Surprise vanished. And the vulnerabilities that had once been an acceptable gamble became a death sentence. Japanese attempts to correct the flaw came too late. In March 1943, Mitsubishi added thin rubber sheets beneath the wings of later aircraft, barely enough to slow fuel leakage from small-caliber rounds. The modification reduced speed and range and provided almost no real increase in survivability. In late 1944, the G4M Model 3 finally introduced true self-sealing tanks, but they cut range by more than 2,000 kilometers, erasing the bomber's biggest strength. Fewer than 100 of these improved models were built before Japan's industry collapsed. By that stage, American air superiority was so overwhelming that even an improved Betty could not survive. The aircraft's design, so perfectly suited for the first months of the war, had become hopelessly mismatched against the realities of 1943 to 1945. By late 1942, the Betty bomber had become the most tragic paradox of the Pacific War. It could fly farther than any bomber in the world, yet it could not survive a single pass from an American fighter. And nowhere was this deadly contradiction more brutally exposed than over Guadalcanal. Throughout August, September, and October of 1942, G4M formations kept launching from Rabaul, each mission requiring a 600-mile flight across open ocean straight into the teeth of the Cactus Air Force. The crews knew their odds. They knew that American radar crews would detect them long before they approached the island. They knew that Wildcats and later Corsairs would be rising to meet them. And most hauntingly, they knew that even a single .50 caliber round brushing their fuel tanks could turn the bomber into a fireball. Yet they flew. Every day, every mission, because imperial doctrine demanded it. At Rabaul, one pilot remarked bitterly to an intelligence officer, "We are not flying bombers. We are flying funeral smoke." The losses became catastrophic almost immediately. On August 8, 1942, U.S. fighters intercepted a formation of 23 Betty bombers. 18 were shot down in minutes, killing roughly 120 trained airmen. Throughout the Guadalcanal campaign, the same pattern repeated. The bombers would appear over the horizon in neat formation, then erupt into flames one after another as American fighters cut through them. By October, entire squadrons had ceased to exist. Japanese commanders could no longer hide the truth. Their most important land-based bomber had become a death trap. The air crews had no illusions left. They flew knowing they would likely die. Allied pilots described Bettys as flying Zippos, cigars full of gasoline, and the easiest target in the Pacific. But American intelligence officers understood something deeper. These men were not incompetent. They were flying a machine whose design philosophy had already doomed them. The losses were so relentless that by early 1943, the Japanese high command admitted privately that the G4M's vulnerabilities were unsustainable. But Japan lacked the aluminum, rubber, fuel, and industrial capacity to design and mass-produce a new bomber. So the Betty continued flying into missions it could not survive. Even the attempts to modify the airframe, adding thin rubber sheets under the wings, minor armor patches, or tiny improvements to fuel lines, achieved nothing meaningful. Every technological patch demanded weight, and every kilogram lost meant less range, less payload, and less alignment with the bomber's original mission. The airframe had been designed around unprotected tanks, and any fix came too late. By mid-1943, American pilots had mastered the exact angles that created the fastest fuel tank detonations. They aimed not at engines, but at the space just behind the leading edge of the wing. A few well-placed hits, and the bomber would erupt in a column of flames so bright pilots said they could feel the heat through their cockpit canopies. Japan's most important bomber had turned into a machine that consumed its own crews faster than the enemy could shoot them down. And yet missions continued, because in the Pacific War, the Betty was all the Japanese Navy had left. By 1944, the Betty bomber had become a symbol of a dying strategy, an aircraft still flown with loyalty and courage, yet hopelessly outclassed by the modern battlefield. American pilots no longer feared the G4M, they pitted the men inside it. And as Japan's fortunes collapsed across the Pacific, the bomber's fate grew even darker. The most devastating proof came during the Yamamoto interception, an operation that exposed every flaw in the Betty's design. Japan's most important military leader, Admiral Isoroku Yamamoto, was flying aboard a G4M on April 18, 1943 when American codebreakers deciphered his schedule. 16 P-38 Lightnings flew more than 400 miles at wavetop height to reach the intercept point. When they found the two Betty bombers, it took only a few bursts of fire aimed at the wings for the Admiral's aircraft to erupt in flames and plunge into the jungle. Not even the architect of Pearl Harbor could survive the vulnerabilities built into his own country's bomber. But the tragedy reached its peak with the Oka missions of 1945. The Betty had been reduced to the role of a delivery vehicle for piloted suicide rockets, massive explosive gliders strapped beneath its fuselage. Already fragile in normal flight, the bomber became almost unflyable with an Oka attached. Its speed dropped, its maneuverability vanished, and its silhouette became even easier to target. On March 21, 1945, 18 Betty bombers attempted to carry Oka weapons into range of the U.S. fleet near Okinawa. Radar detected them early. Hellcat fighters rose from carriers and tore into the formation long before the bombers reached release distance. One after another, each Betty ignited in midair, the Oka charges cooking off in enormous fireballs. All 18 bombers were destroyed. Not a single Oka was launched. By war's end, the G4M was no longer a weapon of strategy, it was a symbol of sacrifice. Its final mission on August 19, 1945 reflected that transformation. Two Betty bombers painted entirely in white, marked with green crosses, carried Japan's surrender delegation to meet Allied commanders. The aircraft that had opened the war with devastating attacks on Clark Field returned 3 years later as unarmed envoys of surrender. The engineers who examined tail number 763-12 at Clark Air Base earlier that same year finally understood the full story. the Betty wasn't a flawed machine. It was a brilliant machine designed with assumptions that no longer matched the reality of a long industrial war. Japan had built a bomber to dominate a war of speed and surprise. But the Pacific War had become a war of endurance, logistics, and overwhelming firepower, a reality the Betty could never survive. In the end, the bomber's legacy was not measured by the missions it completed, but by the thousands of airmen who died inside its thin aluminum skin. Their courage, discipline, and sacrifice could not overcome the physics of an aircraft where a single bullet could transform performance into ashes. And as the white-painted Bettys touched down to deliver Japan's emissaries of surrender, the circle closed on a story that had begun with fire and ended in silence.